Okay, so now we have a horizontal stabilizer. So now we can deflect that for control. That's as a stabulator. And if we experience any unanticipated changes in angle of attack, now, well, it's true the center of pressure of the wing moves forward and tends to want to increase a pitching moment upwards. The stabilizer, if we pitch, let's say, to an angle like this, the oncoming wind tends to give this a lift that maybe it's smaller than the wing, but the moment arm of the lift from this wing to the CG is much bigger. In this case, it's about 50 inches instead of the 2 or 3 inches here. So that can act to stabilize the aircraft. So we're going to want lateral stability too. So what we can do is we can add a vertical stabilizer. And in this case, you can see the aircraft kind of looks like a dart, which, if you've had the experience of throwing a dart, any which way you throw it, because the CG is way forward of the stabilizing surfaces, these static surfaces will always tend to return the aircraft to point in the direction it's traveling towards. Even if you throw it backwards, it will tend to rotate and point the nose towards where it's traveling to. And that's sort of the definition of static stability, which is that if it has a major deviation from, or any deviation from, the attitude relative to the direction it's traveling through the airflow, it will tend to induce a torque about the CG to put the aircraft back in the direction, point the aircraft back in the direction that it's traveling towards. So you might ask, why do we not see aircraft like this? Well, some helicopters do have vertical stabilizers on the bottom half, but the main reason why you don't see this one down here, you only see the one on the top, is that when the aircraft is taking off, it has to rotate to a high angle of attack, and a stabilizer on the bottom would interfere with the ground. So usually we will find that the vertical stabilizer is only in the top half. And so we're missing still lateral or yaw control. So I'm gonna have to put cut for the rudder. And like we were saying, when you take off, the aircraft rolls to quite a high angle of attack, or pitches to a high angle of attack. So often there's a bit of a clearance for the fuselage to get to that angle of attack and not touch the ground, where in this area where we can't put any part of the aircraft. So we can put on the rudder, and now we've ended up with, mostly we've covered everything about the configuration that we started with at the beginning.